What's important in any code repo? Readability. What's a way to ruin code readability in a repo? Adding code before it's needed. So practice just-in-time coding. Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to talk about just-in-time coding, or as it's maybe more widely known from extreme programming, you ain't gonna need it. The basic idea here is quite simple. If you don't need code right now, just don't add it. The way extreme programming talks about it, they don't think you are gonna need it later, so you don't need to spend time working on it now, as there is no payoff in the future. And I broadly agree with that. I prefer referring to it as just-in-time coding, as that makes it clearer to me when I should be coding anything. If it's not right when I need it, it's too soon. What does this look like in practice? Because I think it's easy to see how just adding new unused functions to a code base wouldn't make sense. So these principles must be referring to cases where there is an argument to adding the code now. One example could be when you're working on a PR that adds some new functionality by adding a new class. This class is well designed, has good encapsulation, and you're happy with this class. And you know that in the future, a related feature is going to be added to the codebase. It will be distinct from this new feature and this new class, but you are confident there will be a bunch of shared code. So at this point, you think about pulling out all of that common code now, either by creating helper functions outside the class or by moving some of the code into a new parent class. In both of these cases, you're expecting that adding the new feature will be much easier later, as basically it'll just plug on top of your now previous work. But this is where I think it's important to stop and not split that code now. Don't spend the time now supporting the new feature. Wait until you've actually arrived at the future where that new feature is actively being worked on, and then split that code. At this point, it might feel like this is just a personal preference. The same work is going to happen, so this discussion is just about whether it happens now or later. So maybe it makes sense to delay the work to later so the current PR is released sooner? While that's true, I'd say it's only a small part of the reason not to do the work now. I think there are three main reasons that you should only write the code when you need it. First off, it's possible that you never actually need the change you made. Going back to the initial example, it's possible that even though you are sure that the second feature is going to be added, something happens and it never is added. Maybe the first feature isn't well received and the team pivots. Maybe there's a dramatic change in the company priorities and all of this work is deprioritized. I've generally found in software, no matter how certain you are about what is going to happen next, sometimes you'll be wrong. So if we delay coding up supports for a feature until we are sure we need it, we avoid having spent time on supports that end up just being unnecessary. When you've added the code that wasn't necessary for the current functionality, you've added fluff code. Unlike dead code, fluff code isn't something that clearly doesn't belong. It is getting used and it's required for features to work. But when you look at it, fluff code just feels a bit unnecessary. Fluff code is more verbose than it needs to be, and it just takes a little more time than you think it should to be able to parse and understand everything. It's extra code complexity and a cost that has to be paid in working with this code until either the fluff is removed, which is unlikely, or until it's actually used by a future feature. So even if you are right about this work being helpful for the future feature, it's still adding to code complexity until the point that feature is added, and potentially forever if that feature is never added. Going back to our example with the class getting split in two, either one of those classes could be viewed as fluff, because if someone stumbles onto the code later, they probably aren't going to understand why these two classes exist. As far as they can tell, these two classes seem like they could have been one, but they were split for some reason, and they might even dig in and try and figure out exactly why they were split, thinking they missed something. Overall, this code just feels more complex than it needs to be for no reason. Simply put, the implementation approach you had in mind when thinking about the future feature might not actually be the implementation that makes sense when you actually reach the future. It could be that as time passes, you come up with a better idea, or the team's position on certain approaches change, Or after thinking about it some more, you realize there's a problem with your previous approach. There are countless things that could change and result in you needing to use a different approach. And if this happens, that previous work is probably no longer helpful. Maybe you actually need to go and change it, which takes more time. Or you can leave it, and the only extra time was that original time you spent on it. If we go back to the feature class split in two, maybe when you actually start implementing your new feature, you realize that only half of this base class makes sense for your new feature. So you have to split that base class into two, one of which becomes the actual base class, and one of which becomes this odd in-between class for your original feature. That code is now split between two different classes for no real reason. That's just messy. Trying to future-proof architect changes is one of the hardest things to do, and it's a big reason why I suggest you practice just-in-time coding. John Carmack, one of the original developers of Doom, shared a great tweet on this subject a few years back. It is hard for less experienced developers to appreciate how rarely architecting for future requirements, applications, turns out net positive. Now, with all of those points in mind, I hope you can see why it's a great idea to practice just-in-time coding. One related point I want to make, though, is that this isn't an excuse to make your code hard to modify later. You shouldn't be adding those new classes until they are needed, but you should still have well-structured code that can be modified to add those new classes or features as they are needed in the future. I think I'd summarize this idea as don't extend your code until you need it, but write code that is easy to extend. If you've previously found yourself making code changes before they were absolutely necessary, see if you could try delaying those cases in the future. I think by practicing just-in-time coding, you'll find yourself moving faster and with a cleaner code base too. If you enjoyed this video, please consider hitting the like button below and subscribing to the channel. If you have any comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.